Assalamu alaikum wa rahmatullahi wa barakatuh. Hi, my dear students. Today we are going to talk about Newton's second law. Of course, as you studied in physics, the rate of change of momentum with respect to the time is proportional to the acting force and takes place in the direction in which the force is acting. This means that if we consider that the momentum equals mv and the mass is constant, so the only variable which will be used to make the rate of change will be the velocity, and of course the rate of change of velocity equals acceleration, so ma equals f. And this force is not only one force, it is the net force. It is the resultant of all forces acting on the system. If the mass in kilogram and acceleration in meter per second square, so the unit will be Newton kilogram times meter per second square. And if the mass equal 1 gram and acceleration equal 1 centimeter per second square, so the unit will be 1 dyne. And of course, the unit to convert from Newton to dyne is just by multiply by 10 power 5. And famous units also, kilogram weight, 1 kilogram weight equals 9.8 Newton, and 1 gram weight equals 980 dyne. Let's see an example. A force of magnitude 10 newtons acts on a body at rest. The word at rest means that the body may move, and of course moving from rest means change in velocity. To be precise, the velocity will increase, so we will use an acceleration, and acceleration with a force means Newton's second law. From rest with a mass 8 kilogram to move in its direction, this means the acceleration is positive. With a uniform acceleration, calculate the distance traveled after 12 seconds and its velocity. Of course, we have the force equal 10, and this is the only force, so the net force equal 10. So ma equals f. By substitution, acceleration will equal 5 over 4, and from the kinematics equation, v equal v naught plus at, and s equal v naught t plus half at square, and just substitute. And if you can make an observation for the solution, you will find the solution consists of two parts. The first part is Newton's second law, which is the net force. Just start with ma. Ma equals something. Then use the kinematics equation, and the acceleration is the way to connect between these two forms. Try to solve this problem. Again, you will start with Newton's second law, and please consider that you have here a retardation. Retardation means that there is a resistance acting on the system. So the force of engine is not alone, and maybe the force of engine won't continue in our problem, as we will see later. These are special and famous cases for the Newton's second law. If the force is horizontal and a plane is smooth, force horizontal plane, as you can see in the first case to the left, of course the body is not moving either upward or downward, so mg equal F normal, and we don't care about this part. We care about the net force. The only force acting here is F, so net force equal ma, and then ma equals F. How about horizontal plane? Horizontal means there is a resistance, so F minus R equals ma, which is the net force. Why, mister, we don't say R minus F? Where is the direction of motion? Of course, the resistance is always against the direction of motion. The resistance doesn't make the body to move. It is trying to stop the body. It's trying to decrease the velocity of the body, not making the body move. Do you understand what I'm saying? So the R is always negative because it is in the direction against the direction of the motion. So ma equals F minus R. How about the force is inclined to the horizontal with angle theta? So F cosine theta minus R, which is the net force, equals ma. And by resolving the force, we will find that F normal plus F sine theta equals mg. In the first case, the body is moving with a force without resistance. And the second case, it is moving with a force in the existence of or the presence of resistance. How about the force is stopped? So the resistance will continue blocking or trying to stop the body. So M will equal negative R, and F in this case will be 0. And this is special case. If the force is released or stopped, then the previous equation, especially the second one, we will consider that F equals 0. And you can use it in these three cases. The car uses the brakes or the engine is stopped. So you just say MA equals negative R, or a bullet is fired from a gun horizontally. And please consider that the air is affecting on the system, because this will make the resistance. Do you understand? If the resistance is not here, we won't use Newton's second law because it will be projectiles. Please consider this case, because if the air resistance doesn't exist, it will be projectiles. So to consider this case with Newton's second law, so we are using the air resistance. A pole is pushed through a rough horizontal plane. It is the same in all of these three cases. Ma equals negative R. If a body is moving with an acceleration vertically downward, so the force which makes the body move down is the weight, of course, is mg, and the air resistance is trying to stop or reducing the velocity. So mg minus r. How about a body is projected vertically upward? Of course, there is no any force try to make the body move upward. Do you understand? It is the inertia. The body is projected upwards. There is no any other forces. However, you have two forces trying to reduce the velocity. The first one is the weight and the second one is r. So ma equals negative mg negative r. There is no any positive force in this case. Okay? And of course, don't be confused, because the acceleration will be negative, because the velocity will decrease. In the helicopter, we have a special situation here. The helicopter, the force of engine is always upward, and the weight is always downward, as you can see. However, if the body or the helicopter is moving upward, so the resistance is downward, and this means that ma equals F minus mg minus r. And if the helicopter is moving downward, so r is upward, and the weight, which is the greatest force here, so ma equals mg minus F minus r. Don't be confused that the motion is always in the direction of force. No, it is not like that. Sometimes the weight is greater than the force, as you can see here. The direction of the force is always up, either up or down. So if the plane is moving up, the r is down. If the plane is moving down, the r is up. Okay, everyone? These are the last cases that we have today. If a particle is projected along the line of the greatest slope upward, so we just say with ma equals net force. Okay, so ma equals, what is the force that trying to make the body moving upward? Nothing. There is no any force. It is inertia, as you know. So the same as a body which is projected vertically up, but with angle theta here. So ma equals negative r negative mg sine theta. After resolving the weight, you have here mg cosine theta, and here is mg sine theta plus r. How about it is projected downward, or even it is released to slide downward? So ma equals, of course, the motion, it is in the direction of the weight, mg sine theta minus r. This is an example you can see. A body of mass 3 kg is let to fall. Of course, this means that V initial equals 0. From a height 10 meters, of course, we can calculate the final velocity. It will equal 14. And this is free fall. There is no need to use any Newton second law, but you may also use it because we have here acceleration, which is gravity. Where is the Newton second law, Mr. Sherif, in this case? It will be cancelled. MA equals, what is the force acting to the body? Of course, the only force is the weight. So MA equals mg, so M will be cancelled with M, then A equals g. And this is the acceleration that we are using, which is the gravity. Do you understand? So we don't consider that we have Newton's second law here because it is very simple. However, the Newton's second law will appear after it crossed a 10 meter, is let to fall from a height 10 meter on a sandy ground. Of course, the sand, there is a resistance inside the sand. For a distance 5 centimeters, this means that it is stopped at the end. So inside the sand, we are not using free fall anymore. We have here acceleration, and the distance is equal 0.05 because this is centimeter, and to think 5 centimeters, this means that it is stopped at the end. So V final equals 0. We found that acceleration equal negative 1960 meter per second square, and move to the Newton second law. Of course, we just start with MA. The force acting on the system is the weight downward and the resistance upward. Please revise the previous slide. MA equals mg minus r, and you can see that r equals 5909.4 Newton. And by divided by 9.8, we can find the resistance because you need to find it in kilogram weight. So it will equal 603 kilogram weight. The last problem today, and it is a very special problem. A train of mass 220 tons moves along horizontal straight rail route with a uniform velocity of magnitude 29.4 meter per second. Please focus on this word, uniform velocity. This is not Newton's second law. Till this statement, it is only Newton's first law. So we can just say that we can just say that F equals R. The force of the engine of the train equals the resistance of the road. Do you understand? So the first two statements, we just say that F equals R, where R is the total resistance. The velocity was 29.4 meter per second. During the train's motion, the last car of mass 24 tons is separated and moves with a uniform retardation to stop completely after 1 minute of the separation moment. We need to imagine this situation. What will happen after a car is separated from the train? Do you think that the velocity of the train will be the same after separation? Of course, it will increase, and I will give you an example. If a body is carrying a load of 1 ton and this car is moving with velocity 20 meter per second, again, a car is moving with a constant velocity or even maximum velocity 20 meter per second, and it is carrying 1 ton, and suddenly the weight is dropped. What will happen? The car will move more faster, of course, because a load is dropped. The velocity will increase. It is a principle of physics. So after the separation of the last car, the remain of the train the remain part of the train, its velocity will increase with an acceleration. Do you understand? And the last car will move with a negative acceleration because it will stop at the end. And the velocity of the car before separation will be the same the velocity of the train. Do you understand? Okay, let's use all this concept to solve the problem. The magnitude of the resistance per ton of the train mass. Of course, at the end, we have here V equal V naught plus 80. We study the motion of separated car. We are using now the car only. V equal V naught plus 80. Of course, V final equals 0. V initial equal 29.4. Someone would say, Mister, this is the velocity of the train, not the car. The moment that the car is separated from the train, it gained its velocity and start to reduce. Do you understand? So the velocity of the car is also 29.4, the initial velocity of course, plus 60 times a, because he said after 1 minute. So the acceleration of the car and the car alone equals negative 0.49 meter per second square. And the mass equal 24 ton and V initial equal 29.4. From the equation of the motion, of course, ma equal negative r. Do you remember? The case which is the force of engine is stopped. Do you remember? So ma equals negative r. And please consider that he said that the total resistance, it is the same as the velocity of it is the same as the force of engine, as you will see. Okay, we have here ma equals negative r, so the mass times a equals negative r, so r equals 11,760 newton. This is the total resistance. Then r equals 1,200 kilogram weight, and then r equal 50 kilogram weight per ton. This is very important. This is the resistance per ton. If you need the resistance for the whole train, we multiply by the mass of the whole train. If we need the resistance of the car of the train, we just multiply by the mass of the car of the train. So you need to find the resistance per ton, and we found it 50 kilogram weight. Okay, the distance traveled by the separated car within a minute after separation. Again, the distance traveled by the separated car within a minute after separation. Of course, the acceleration here is negative 0.49 and t equals 60 seconds. So the distance of the car equals 882 meters. Now we need the distance of the train, of the remain of the train after 1 minute. Do you understand? Then we subtract them from each other. We need to study the motion of the train before the separation. Of course, as we said, that it is Newton first law. So F equals 50 times 220. Okay, so it will equal 11,000 kilogram weight. Okay, everyone. And then we can just say that ma equals f minus r. So after the separation, of course, we said that we are using acceleration, this a for the train, this case. So ma equals f minus r. After we substitute, we found a equals 3 over 50. And of course, the resistance per ton equal 50 kilogram per weight. So we need to find the resistance for the remain part of the train. The mass will equal 196 in the ton. So we will just multiply by 50 kilogram weight to find the total resistance of the train. Do you understand, everyone? From the law of motion, so the distance for the remain part of the train will equal 1872. So we just subtract the distance of the remaining part of the train minus the distance of the car, and we will find the distance between them, and this is what we need to find. Thank you so much, and I will see you soon.